All right, so we're gonna, number one, graph the given function. So first we're looking at it, it's absolute value function. We have to go right 2 and up 3. So absolute value function, I'm gonna draw the parent function in first. And then we're gonna go right 2. I'll do that in black. Each point, each of those key coordinates, I'm gonna go right 2. Draw it again. And then the last part is go up 3. So up 3, each point, each coordinate, and redraw it. Green is the only one you need for the answer. It's the only graph you need. The others are good to have, so I can give you extra more credit. All right, looking at the next one, it is a cube root function. Parent function is, make sure I got, oh my goodness, that is upside down. Just noticed that those numbers are all over the place. That's a cube root function. It's a reflection. And so if we reflect it, take those points, reflect. Looks something like this. And lastly, it's going to go right 1. So each one of those points, make them go right, right 1. Erase that one. And redraw. And in green, that is your answer. That's the only one you absolutely need on the test. All right, looking at our next one, we have, we have to write the equation for this. So there's a cubic function. And cubic function 0, 0, 1, 1, negative 1, negative 1, those are the key coordinates. Now we're looking at where the main coordinate I look at is this 0, 0. That's where the graph really flattens out. The slope flattens out to almost like 0. So on that graph, on the black graph, that would happen right here. That's the key coordinate my eye is focused on now. If you look at the graph itself, the orientation of the graph, they're exactly the same. You'd be able to slide the green right over the black and it would work. So there's no reflection that happened. So let's focus on 0, 0, moving to that point there. So we're gonna move it to the right 1, 2, 3. And up 1. Oh my goodness, that's an ugly color. Blue. Up, oh my gosh, 1. All right, so now I'm gonna take these words and I'm gonna put an equation to them. So cubic is y equals x cubed. Right, if we go right 3, looking back at your equation, it's going to be put in parentheses with the x, a minus 3. And to go up 1, you go y equals, so x minus 3 cubed, that's the right 3. And then up 1 is on the outside plus 1. And there's your equation for that function. Number 3, here we go. We got it. It's only, I should have an arrow over here. My bad. Because it does continue. This is the only parent function that has a starting point. This is a square root function. Square root function typically starts 0, 0, 1, 1. And that's the parent function. Well, right now you can't take this blue parent function and slide it down and it will overlap the red one. There's a reflection that happens here. So to show that, what is actually happening, if we reflect that graph, 1, 1 will get reflected down to 1, negative 1, and it'll be upside down like this. Well, now I can take that black function that I just drew and I could slide it down and it would slide right over the top of the red, or be pretty close. So it's a reflection. Now the point that, once we have that down, now the point I'm looking at is still 0, 0. That is the starting point of a squared function. So that's the easy one to look for. And right there, that point there is what I'm looking at. So now from 0, 0, how do I get down to this point here? You go left 1 and down 1, 2, 3. Oh my goodness. Down 3. Now to build these equations. Build the equation. We're going to start off with square root, which is y equals square root symbol x. Do a reflection on that. Reflection just means you put a negative after the y. Left 1. So with the reflection, go left 1. That's plus 1. And then they go down 1. So we have the reflection that happened. We have the left 1. And then we're going to go down 3. Minus 3. And there's your equation. All right, moving on to one of them that I made a mistake on. So I have rational functions here. And thank you, someone caught that. Thank you, thank you. We have, it's a rational function, 0, 0, or 1, 1, negative 1, negative 1. And we have our two portions of the graph. This is a parent function. It's a rational, I should write that down. Rational function. I drew up the parent function, and what I would suggest is you just concentrate on like the top right portion of the graph or the bottom left. Look at one, not both. Reason why is right now you should be able to see you can take the red parent function and slide it, and you should be able to move it so it overlaps the black. That means that there's no reflection. The next thing we have to do is we have to take a look at 1, 1. Where on the black graph would 1, 1 transform to? Where would that move to? And there's only one. If you look all the way along the black graph, in the middle of the curve, there's only one point right here that is a nice integer, no decimals, point. So from 0 or 1, 1, it goes 1, 2, 3, 4 to the left. So left, 4. And that will be it. The bottom one would do the exact same thing if you follow that 1, 2, 3, 4 to the left. So now we have a rational function. So I'm going to write the equation y equals 1 over x. Left 4 is y equals with the x. Left and right is always with the x. X. And left 4 is plus 4. I would put it in parentheses. It'll be better if you put the denominator in parentheses. Always right. Never be wrong doing that. So put it in parentheses. You'll be good. Number 5. I have, it's a quadratic. Quadratic typically is U-shaped. This one's upside down, so this is a quadratic. U-shaped, it's upside down, so what does that mean? Hopefully you're saying reflection. So it reflects, so if I reflect these points, it'd be upside down. That's awesome, it's upside down, that's great. Now I need to pick a point, a key coordinate that's easy to find on our new graph. Well, to me, that's this maximum point, the vertex. And I can pick it out on the other graph, on the graph that was given to us originally. And doesn't look like much is happening here. Just looks like a left 1. So left 1, so now I'm just going to build the equation. So quadratic, it's a reflection. Reflection, put a negative right after the equal sign. And the left 1, we got the negative, that's the reflection. Oh no. Parentheses, x plus 1, and it's a quadratic, so squared. And there's your final answer. 6, exponential. This is an exponential function. It starts out really flat, and then it goes up super fast. Typically an exponential function, or it goes through 0, 1. Starts down flat along the top of the x-axis. There's an asymptote right below it, and then it goes up super fast. Right now, you could take that red graph, the parent function I drew, and slide it down, left, right, one of the two, and or one of them, and it would actually slide right over the top. So there's no reflection that happened. And now I'm going to look at the black part of the graph, the graph that was given, and I'm going to go kind of right in between, or right in the middle of the curve. There should be a nice coordinate that is going to take, that's our nice coordinate that goes from 0, 1, and it will shift down to 0, -3. So that's going to go down, oh my goodness, down 4. And drawing that graph now, you have an exponential function, y equals ISA e. You can have 2 there if you want, it doesn't matter. And then down 4, e to the x, and then -4 afterwards, right at after. Number 7, we have, looks to be a cube root function. Looks like pretty flat S looking. If you see, the orientation isn't right. I could not slide the black parent function I just had. I could not slide it, and it would trace the red at all. You couldn't do that. So that means there has to be reflection. So it's a cube root. There's a reflection. If it reflects, it'll look something like this. And then the main key coordinate I'm looking at is 0, 0, because that's where the graph kind of gets pretty vertical. The slope gets really vertical, and where that's happening on our red graph here is right there. I'm not always going to point it out, but there's always a nice coordinate there. 1, 2, it's a nice coordinate right where it gets really up and down vertical. So it's down 3. Now let's build the equation. Cube root function, like a square root, but a tiny little 3 there. Reflection, put a negative after the equal sign. And down 3, so we have a negative, which is the reflection. And down 3 on the outside, and there's your equation. All right, come to class with